Wrap that literally will be the last talk, at which point we can go home. But I will also say that this is the talk I've waited for a long time. So I'm hoping, Rich basically was telling me behind there that if he runs over, I should stop him. I'm warning you that I won't, because I actually want to hear this talk. So if you get really, really bored, like all of you can do the little chopping motions, because I'm not going to do it. Having said that, our last speaker today is Rich Harris. Rich is the graphics editor at New York Times, but he's here to talk about two things. One is, well, I hope I say that right. The name in itself is awesome, but the second part of it is just kind of like a backstory. When we're thinking about this whole agenda, I wanted to actually have a little conversation about HNPWA, which is the Hacker News PWA site that was talked about at I/O, where you can find examples of PWAs for every front-end framework, like complete examples that you can unpack and look at. And I was like, is there anyone from New York who has that? And wouldn't you know? So I was like, would you do it? And he said yes. So I'm really looking forward to this. Svelte is really fascinating, and also hoping to hear a little bit about HNPWA. Thank you.
Hi everyone. So my name is Rich, and I do work at the New York Times. I'm a journalist. I work in the investigations team at the New York Times. I've worked in the news industry for about 10 years now. The last 5 years or so of that, my focus has been on using JavaScript to tell visual and interactive stories. Before the New York Times, I was at the Guardian US, which has an office just up the road from there. And we've actually built a couple of progressive web apps at the Guardian last August to coincide with the Olympics. We built this thing called Rio Run, which is a 4-hour audio documentary about Rio de Janeiro disguised as a running app. We wanted to do something about the city itself as opposed to about games, because everyone does a lot of journalism about games, and we thought that it was really fascinating to learn about the effect that the Olympics had had on the city and the people who lived there. So we did this running app whereby if you put it in your pocket and put some headphones on and run around the city, then the GPS on your phone will track how far you've gone, and it will parlay that into distance along the Rio Marathon route, which takes you from the San Madrone down here, past Flamingo Beach a few times, and then back along there. 26 miles, 26.2 miles of running and audio, and as you're running along, you will hear things about the city and its people and its history and its politics. You'll get running tips from an Olympic marathon coach, and you will hear ambient audio that's recorded in the neighborhoods that you're running through. And obviously, a lot of the features in a thing like this can only really be done effectively as a progressive web app. For one thing, if you're going to use geolocation, then you need to be serving over HTTPS. And for another thing, once you leave the Wi-Fi bubble of your flat, it's quite likely that you'll have bad connectivity. You probably don't want to use your data plan using all of this audio. So it's really nice if you can have a saving audio for offline use feature, which we implemented on Android, and which people did in fact use. Most of all though, the reason that we wanted to do this as a PWA is that it's a really big ask to say to someone, if you want to experience this piece of journalism, you have to run a marathon. You certainly don't want to do it in one go. And so what we wanted to have was a situation that people could do a couple of miles, put it away, and then the next time they went for a run, they could pick up where they left off. And so for that, it has to be installable to your home screen, has to have the icon, which means that it has to have a manifest, it has to have a service worker, all of this stuff. So it was only really doable as a PWA. And people did in fact run a marathon about a week after we launched it. The guy in Norway completed the first marathon. And then a couple of months after that, for the presidential elections, we did our live results. Every news organization does election results. It's kind of a thing that you have to do whether you want to or not. And traditionally these pages are kind of a giant fact file, if you like to call them. It's just a lot of information, a lot of charts, a lot of numbers. And we wanted something that would be your companion throughout the night. If you're watching CNN on your sofa, or if you're out at a viewing party with friends or something like that, our app would, as well as giving you all of the information, it would try and contextualize it. It would give you information about what it meant that Donald Trump had just won Wisconsin, for example. And again, for something to fill that role, it needs to be installable as a home screen app, ideally, so that people can revisit it. And a thing that we did that I'm particularly proud of is we had push notifications that are actually alerting you as key developments happen in the race. And so that meant that the app was always available as a lock screen bar if you're on Android, and that had the most recent development plus the results in the presidential race so far. We thought that we might get maybe a couple of hundred people signing up for these push notifications. It was a bit of an experiment. We thought we could get 400, that would be a massive success. We got 33,000, and then our server died, so it probably would have been more. But again, all of this stuff can only really be implemented as a PWA. So it's deeply non-traditional in journalism to build things like this, but it really does work. And this was actually the most viewed piece of content that The Guardian has ever had. It had millions of people all around the world looking at it and interacting with it as a PWA. And I, for one, I'm a huge believer in PWAs, even if it is to some extent a kind of a nonsense marketing term. It's something that really does fill an underserved niche between experiences that people want to have once and experiences that someone will commit to in the form of a native app download. And so I hope to see more of this sort of thing. When I'm not doing journalism, I'm doing this. To the extent that I'm known in the JavaScript community, it's as the creator of Roller, which is a JavaScript module bundle which is used to build all of your favorite libraries. But I'm not here to talk about Roller or indeed about PWAs for the most part. I want to talk about something else. And that is the problem that we are shipping too much stuff. And the reason that we're shipping too much stuff is because we used to write code like this on the left, where you would have some HTML and you would have some JavaScript that referenced the HTML and it would tell the HTML what it needed to be doing at a given moment in response to user events. And we started doing stuff like this instead. Now, the code on the left, if anyone's written code in this style, you'll learn very soon that if you build much of it, it becomes this wild spaghetti maze of nonsense, and it's just very hard to maintain. It gets quite brittle quite fast. This stuff on the right-hand side is a lot easier to deal with, and it's a lot more scalable, because rather than saying what needs to happen at any given moment, you're saying what the app needs to look like. We've got this render function here, which is just saying this is what the application should look like given the state of my app. There's a wrinkle though. On the left, this code will run anywhere. On the right, this code will only run somewhere that you've already included over 150 kilobytes of minified framework code. And that's a little bit of a problem. Now, this is a snapshot taken on my phone. It's quite a recent high-powered phone, an Nexus 6P. The combination of parsing React and React DOM together, you're looking at almost 200 milliseconds after all of the network activity has taken place, which is not completely insignificant. Now you might say, that's not really a problem, 200 milliseconds is a blink of an eye or a clap of a hand, it doesn't really affect anything. And I will concede that if all of your users now and forever are on the wealthy Western web with high-powered devices and an LTE connection, or if you have the luxury of working on an application where you're not competing for resources with analytics and ads and images and everything else, or if by it's not a problem, what you mean is you have bigger problems, then I will concede that it's not a problem. But for everyone else, it is a problem. It's a problem that we need to solve. The first law of thermodynamics is that energy cannot be created or destroyed. There's a finite amount of it. It can only be transformed from one form to another. Heat can be turned into light, electricity can be turned into motion, pretty useful stuff. This is kind of the most fundamental truth of the universe, and what it means ultimately is that nothing is free. Everything somehow has to be paid for. And I'm telling you this not because I think you don't know it, but because I find it to be quite an illuminating conceptual framework for thinking about something that we deal with all the time, namely complexity. If you go back to our code samples before, the code on the left has, as we said, as it scales, it becomes difficult to manage. We end up with what I call cognitive complexity. You've got to keep a lot of stuff in your head at any given moment if you're trying to understand what a piece of code in that code base does. On the right-hand side, our job is much simpler. We're just saying what the app should look like at any given moment, and this magical mystery box turns that declarative intention into a set of behaviors that the browser can then respond to. But the complexity hasn't gone away. What we've done is we've taken the cognitive complexity on the left-hand side and we've turned it into this runtime complexity in the magical mystery box that then has to accompany your application around the globe on every device that your application runs on. So it feels like we've got this dichotomy between better user experience on the one hand, writing really low-level imperative code that's hard to follow, and a better developer experience on the other. And we as developers are forced to choose. Or are we? There's a nice anecdote that I like about tourists visiting Ireland, national directions to Dublin, and the Irishman says, well, if I were you, I wouldn't start from here. And so I want to pose a question. What language are web applications written in? Anyone? Shout it out. You're all wrong. It's HTML. Web applications are written in HTML, which can contain JavaScript and also CSS. If you think about it, when you're building a user interface, your fundamental task is to create HTML. Maybe you want to be technical and say that you're actually creating and manipulating DOM, but when you look at the element inspector, what you see is a tree of HTML. And so, given that everyone learns HTML and CSS before they start writing JavaScript, it kind of makes sense that the input code should match the output code. And so we kind of realized this a few years ago. Some very smart people said, well, given that we're writing JavaScript applications, let's put HTML in our JavaScript. And so JSX was invented. And JSX is pretty cool. But it has some kind of sharp edges that you need to be aware of. This is valid HTML, but it is not valid JSX, because in JSX every element has to have a closing tag, even if it can't contain any children like an image. You have to quote all of your attributes in JSX. In HTML you don't, which is kind of nice if you're dealing with, for example, numerical values. If you're building lists and tables and things like that, you don't have to close all of your tags, which gives this nice kind of airy, readable code. That would not compile as JSX. And nor would this. If you're working with something like Illustrator and you take the code that it generates and try to incorporate it into your web application, then you'll discover that xln_xlink is not a valid attribute in JSX. And then there are all the things that are valid JSX but don't behave the way that you would expect them to. For example, you cannot have strings as inline styles because styles in JSX have to be an object, and the keys have to be camel-cased and the values have to be quoted, which is kind of gross occasionally. And then you have div class equals foo. That won't work because in JSX it has to be class name instead. And then we have label for. So we have two checkboxes here. The bottom one is checked because frogs are better, and that one works as JSX because it needs to be labeled HTML4. And there's a name for this phenomenon when something is very close to the thing that it's trying to be but not quite. And the name for that is the uncanny valley. And it's kind of repulsing to us when something is so close to what it's meant to be but not quite, and you get all of these edge cases that are just small enough to be really confusing. But JSX does prove one thing, and that is that HTML is a superior language to be building user interfaces with. And I'm going to prove this to you by analogy. My vegetarian friends always tell me that they really like being vegetarians and they enjoy the vegetarian diet. And then I go to the supermarket and I see stuff like this. It's like, if vegetarian food was so good, there wouldn't be a market for meatless sausage patties. The existence of porn proves that humans are supposed to eat meat, just like the existence of JSX proves that web developers are supposed to write in HTML. Okay, it's rebel time. I don't know how I'm going to hold the microphone and do this at the same time, so I'm just going to shout at you. This is designed to give you a bit of a flavour of what building in Svelte is like. So I'm going to start by creating a single element like that, just writing some regular HTML. And then I'm going to replace that text with a variable called name, which you can see is declared down here. And so if we change that, then we can see the user interface updating from the top. Now this component has been turned into a JavaScript object with an API that we can manipulate directly. Like that. So it's got kind of a limited amount of state management sort of built in. If we wanted to make this interactive, then we could do something like this. We'll add an input tag and we'll bind to the input event. And then we'll use that same set method to update the data directly. Now this is quite a common thing that you need to do to bind to data in your application, so there's actually a shorthand available in Svelte which looks like this. And you get the idea. Now, because this is HTML that we're writing, we can also do some CSS. We can do this and this. And the interesting thing to note here is that rather than having to run the svelte.js script tag on our page, Svelte is actually turning this into code that runs itself. You can flip this over and see what it's generating. This add CSS stuff up here, you wouldn't actually have this in production. This is basically just for the REPL. In production, it would get extracted out into a separate CSS file. And then down here we have some code which is actually doing all of the heavy lifting for us. And then we have a few lines of boilerplate which comes to just under 250 lines of code. And then as you add more components, some of that code gets deduplicated, so it actually scales really nicely. Now at this point, people say, well, that's all well and good, the ergonomics seem quite nice, but I'm a JavaScript programmer and I want to be able to use the things that I can use in JavaScript, like if statements and for loops. Well, we have if statements, they look a bit like this. And we have loops, they look like this. Move that over a little bit so that it all sits on one line. And this behaves more or less as the array functions that we're used to already. You can do this sort of thing. Make that one based rather than zero based. You can have arbitrary JSX expressions inside these tags. It looks like mustache, but it's not mustache. And it's essentially as flexible as you need it to be in order to build pretty complicated web applications. And the advantage of doing it in this manner is that the compiler understands quite deeply the nature of your application and understands what's going on inside it, what all the different ways that it could end up looking like are. So a few more examples of how this works. You can have nested components, obviously, and if we were to change the styles on this nested component, right, the bottom paragraph is red, the top paragraph is still black, even though we're just writing plain old paragraph tags. It's getting scoped to the component so that you don't end up with the nasty CSS conflicts that plague so many code bases. If we were to add another selector, like this, it would tell us that there's a warning, and we need to check the console to see what that warning is. And it's actually telling us that we have an unused CSS selector, because we don't have a class equals foo anywhere, so we don't need that, and it'll just remove it. If we did have a dynamic class, then it wouldn't be warning us that because it wouldn't know that we weren't using that selector. And it works really nicely with SVG, and we can do data list stuff. Nice responsive chart. And it's basically flexible enough to do the vast majority of web development tasks. There are some benchmarks available. I won't bore you with the details other than to say that it's extremely fast because it's compiling down to fairly low-level DOM manipulation. It's not doing this kind of diffing process. It's directly updating the nodes that have new data. Now this is an example of what is known as the principle of least power. And someone named Tim Berners-Lee once said, computer science spent the last 40 years making languages which were as powerful as possible. Nowadays we have to appreciate the reasons for picking not the most powerful solution, but the least powerful. The less powerful the language, the more you can do with the data stored in that language. It's quite a profound insight, and it seems a little bit paradoxical, but think about all the situations in which you can use JSON, for example, where you can't use JavaScript. This is what the principle of least power means. The more restricted a language is, the more declarative it is, the more places you can use it. And what that means in Svelte terms, these are some of the advantages that you get from that declarative nature. Because we can understand exactly what's happening in your component, we build applications that have fewer bytes and are therefore faster to parse and start up. It updates extremely quick. Server-side rendering is many, many times faster than the equivalent server-side rendering with something like React, because that template that we saw earlier can be compiled to something that just generates a string, instead of needing to generate a tree-like object that then gets stringified. It has a tiny memory footprint on par with vanilla.js. You can do static analysis of CSS, solve the append-only style sheet problem. The interop holy grail, this is something that we haven't really solved up to this point. Like if you're building an Angular app, you can't use a React component. If you're building a React app, you can't use an Angular component. But in either case, you can use a Svelte component because it's not adding another framework that you have to ship in order to run that application. So Svelte components can be turned into web components with very little effort, and then they can be used wherever. They can be used in Envo apps, they can be used in Vue apps, they can be used wherever you want. And the corollary of that is that you end up with regret-proof code bases. If you decide now that you're going to build your application in React and then decide next year that you're going to switch to Vue, then unless your app is small enough that you can do a big bang rewrite and get it out the door, there's going to be a transitional period where you have to ship to frameworks, and that's really, really suboptimal. But if you're using something like Svelte, then that's not really a problem because there is no framework. The framework is in the code itself. You're only paying for what you use. One quick example of how we're using Svelte at the New York Times. This is a story that we published just last week about a subreddit where people were arranging drug buys. And we wanted to show the comment history of two of the people in this story who had died of drug overdoses. I'm just going to refresh the page quickly. Now, because the website itself is fully responsive, all of the graphics that go on it is fully responsive. As this gets smaller, it's scaling down in such a way that all of the boxes that you see there are always lined up with pixel edges, so it always looks perfectly crisp. And if you go down to a mobile width, then it stops bucketing by day and it starts bucketing by week. So it's really responsive. It's a combination of canvas and SVG. You couldn't do this as static images. It has to be done with code. If you did do it as images, then it would be many times larger, and it wouldn't look quite as sharp, and it wouldn't be as responsive. But because there's so much going on this page, we've got all of the related content, we've got analytics, we've got ads, we've got comments, we've got all of this stuff. The last thing we want to be doing is shipping a framework like React or something like D3. We want to be respectful of our users' bandwidth. And so instead, I built these charts with Svelte. There's one there and there's another one further up. Two of these charts combined come in at about 7.5 kilobytes. A lot of that is the data powering the charts. So that's really tiny. And it's even possible to, because of the SSR capabilities, it's possible to generate an SVG version that can be used in print as well. I've talked quite a bit about file size. And so I feel like I should maybe address the file size fetish briefly. Tom Dale, the noted thought leader, says, "It is this emphasis on file size that leads the JavaScript community to its simplicity fetish. When file size relies on simplicity, and speed relies on file size, and speed is paramount on the web, then we have to pretend that simple tools are the best tools. What other choice do we have?" And it's quite an illuminating thought. If your answer to thinking that React is too large, for example, is to use a React-like library which is smaller, then you have to be aware that React isn't larger because it's written by people who are very, very good at their jobs. They are extremely good at their jobs. The React-like libraries are smaller because they do less stuff. And so traditionally there's been this coupling between the file size of your application and the amount of stuff that you can do, because normally frameworks are built on the notion that if you're going to use a feature, it has to be part of the framework and it has to get shipped to the front end. But if you're compiling from a declarative template, then you don't actually have that problem because you know in advance which features are being used. So compiling from templates means that your features become cost-free. Some of the features that you can get through this approach, for example, really good errors and warnings. For example, if you have a typo in your component definition, then Svelte won't just tell you that something is wrong, it will use a string distance algorithm to figure out what you probably meant, and then print something that you can copy and paste back into your application. We have fully declarative transitions when elements enter and leave the page, computer properties, value-based list diffing, complex media event handling, stuff that is ordinarily quite costly. And a lot of these features are things that would be quite difficult to justify if you had to ship them for every app, whether or not your app actually used them. So this, I hope, answers the earlier question. Is there a solution to the dichotomy between cognitive complexity on the one hand and runtime complexity on the other, or between user experience and developer experience? And the answer is yes. You shift that complexity into the build step instead, where it really doesn't matter. You can have all the complexity you want because the user never has to experience it, and you as a developer don't have to deal with it either. How am I doing for time? Okay, so I thought, given the hands-on nature of today, rather than talking about how I built the self-hacking progressive web app, I will try and build one in front of you. Probably a terrible idea, but bear with me.